Hello, this is Mrs. Ross, and this is Module I, Unit 1, Lesson 1, Introduction to Energy, Part 2. I believe we ended up on page 10, and I think the first video cut me off while I was answering what does chemical energy in a compound depend on. The definition of chemical energy is here, where it says chemical energy is the potential energy stored in the chemical bonds of a substance. Chemical energy is the potential energy stored in the bonds of chemical substances. In the chemical bonds of substances. I'm sorry. And then the next question, it says, what does chemical energy in a compound depend on? It's the next sentence. The chemical energy in a compound depends on the position and arrangement of atoms in the compound. The chemical energy in a compound depends on the position and arrangement of the atoms in a compound. So get that down and we'll continue. You can pause this video if you need to. All right, sources of chemical energy. So we're still on page 10. It's the very second to last sentence. Sources of chemical energy include batteries, fuels, and matches. Batteries, fuels, and matches. And then our next definition here, nuclear energy, should be the very first sentence here. Nuclear energy is the potential energy stored in the nucleus of an atom. Nuclear energy is the potential energy stored in the nucleus of an atom. So when is energy released? Let's see. When the atom's nucleus breaks apart, or when the nuclei of two small atoms join together, energy is released. So basically when the nucleus either breaks or if it fuses with another nucleus, energy is released. And that's going to be the answer to this last question before we get to what type of energy is given off by the sun. Okay, what type of energy is given off by the sun? The energy given off by the sun comes from nuclear energy. So that would be nuclear energy. Wait, there we go, right there. And what would happen without the nuclear energy from the sun? That's going to be the last sentence here. Without nuclear energy from the sun, life on Earth would not exist. Without nuclear energy from the sun, life on Earth would not exist. Okay, so let's do this quick check. A toy robot can walk and talk and runs on batteries. Which type of energy is stored in the batteries? And it's going to be chemical energy. It's actually chemical energy. Okay. All right, let's go to page 11 and talk about energy transfer and energy transformation. Okay, so an example of energy transfer. So it says when you roll a ball across the surface, you know that the ball has kinetic energy because it's moving. What will happen if the rolling ball then hits another ball at rest? The ball at rest will start moving, which means now it has kinetic energy as well. This is an example of energy transfer. So an example of energy transfer is when a rolling ball hits a ball at rest and the ball at rest starts rolling. Don't know how you're going to write that down. When you have a rolling ball hits a ball at rest, the ball at rest starts rolling. Okay? So let's get the definition for energy transformation. So we are here. Energy transformation. Okay. So we have an example. Okay. Right there. So in the second paragraph, the second sentence, it says, this is an example of energy transformation or the change of energy or the change of one form of energy into another. The change of one form of energy into another. That's going to be your energy transformation. Let's see. So what forms of energy can change into another by energy transformation? Any form of energy can turn into another form of energy in energy transformation. Any form of energy can turn into another form of energy in energy transformation. Okay, and then we have another quick check. Which of these statements is an example of energy transfer? And it's going to be this first one, an open flame heating a pan of water. We're going to keep on to 12. So if this is 11, this is 12. So 12, where does the chemical energy in the food, let's try that again. Where does the chemical energy in the food we eat come from? That question is awful. Basically, it's saying, where does the chemical energy that's in our food, where does that come from? And this first sentence says, do you know the chemical energy in the food you eat originally comes from the sun's energy? So you can write, it comes from the sun's energy. An example of an energy system, let's see if we can find that. Energy system. Oh, here we go. Right here. This last sentence says this entire process is the example of an energy system. So let's see. This is when the electromagnetic energy from the sun travels to Earth. It goes through the photosynthesis in the plant. The animals eat the plants. We eat the animals, and then we run a marathon. What? So it's the example of an energy system is the energy from the sun growing the plants, animals eating the plants, us eating the animals, and us using that energy in our bodies. And then it has, what is the definition of a system? Oh, here we go. A system is a group of interacting parts that move or work together. A system is a group of interacting parts that move or work together. How does any one part of a system work? Let's see. How does any one part of a system work? In order to do work, any one part of a system, the energy must be put into the system. So for any one part of the system to do work, the energy must be put into the system. And there are two types of systems. That's going to be on 13. So let's see. Types of systems right there. Let's see. So systems can be natural or what? Or they can be designed. My bad. If I would read the entire sentence, I would have it. So under two types of systems, we have systems may be natural, such as a tree, or they may be designed, such as a wind-up toy. So for your example of a natural system, a tree is a natural system all in itself, creating oxygen from carbon dioxide. And then an example of a design system would be a wind-up toy. All right, so we're going to skip a few pages here and go to 16. And I want to say, is this the last part of this? No, we still have more on 17. Okay, so we're right here where it says, what is a serious concern of engineers and scientists today? So let's go to 16, 13, 14, 15. Oh, right now. Oh, I thought that was 15, but it says right here, a serious concern of engineers and scientists today is energy storage. What is difficult to store efficiently? Energy is generally difficult to store efficiently. Why are new technologies constantly under development? New technologies are constantly under development for storing energy in a variety of ways. Why? Oh, for this reason. For this reason, new technologies are constantly under development because energy is difficult to store. What is another issue for energy consumers and producers? Another issue for energy consumers and producers is energy distribution. That's down here in the second paragraph. So, what am I doing? Okay. Why must the delivery of energy be carefully controlled? The delivery of energy must be carefully controlled. Too much or too little energy released at once can be disastrous. Too much or too little energy released at once can be disastrous. So, and then, let's see, do we have the definition of power here? Oh, right there. Okay. So, the distribution of energy over time is referred to power, or the rate of doing work. So, power is the rate of doing work, or you could call it the distribution of energy over time. That's actually the same thing, believe it or not. Okay, and then let's define the perpetual motion machine. Okay, so right here it says called perpetual motion machines. These machines would use as much energy as they generate. So basically these machines, in theory, generate energy that allows them to use the energy, to generate the energy, to use the energy, and it's perpetual, which means it doesn't stop. An example of a perpetual motion machine. So I have the overbalanced perpetual motion, overbalanced wheel. The overbalanced wheel would be an example of a perpetual motion machine. Let me see if they have another one. Nope, that's it. Okay. So you can see on this wheel we have different weights on each arm. So they thought that might be a perpetual. It's not. There is no such thing as a perpetual motion machine. All right, let me know if you have any questions.